Hey guys, so this is the first video for regular expression. I will have a series of videos on regular expression, and regular expression I expect it to be probably around like 5 videos on regular expression. It's very powerful. I really liked it, and it's very flexible, and it can be as complex, as you want it to be. So yeah, I'll demonstrate to you some of the more advanced syntaxes in the regular expression. But first, let's start off with something very basic for those beginners who don't know what the regular expression is. Regular expression basically it's an expression that allows you to pattern matching a string. A string could be any kind of string. It could be a file with multiple lines of string, and it also can match multiple lines as well. So regular expression is used for for you to look for some kind of pattern inside the string, and then perhaps do some search and replace within that pattern. And you can do different ways. You can have comments in your regular expression. You can have multiple lines in your regular expression. But for now, I'm just going to show you the very basic ones. Okay, so let's get started. Okay, so I have prepared some files here. I prepared a log file. In this video, I'll show you how to extract out the information from the log. I have prepared 2 Perl scripts and a sample text file. Okay, the reason I use Perl is because in my opinion, Perl pretty much sets the standard for regular expression. It is the language that uses regular expression extensively. It's very powerful for Perl to do regular expression. So I really like to demonstrate regular expression in Perl. But keep in mind that some other languages or utilities like Unix commands, they also use regular expression, but some of them are not fully compatible with the Perl, because Perl has the regular expression for Perl is a much bigger scope than the regular expression in Unix command. Because some of the more complex syntax is not supported in Unix commands or Java or sort of. So Perl is pretty much sets the standard, like I said. So let's demonstrate something. So I have a Regex. That's the short short term for regular expression, instead of saying the 2 words. So regular expression.pl, regex.pl. Okay, so in this PL I can run. So if we open this one in here, okay, now you see I have you don't have to really understand the Perl syntax, but just keep in mind this is the regular expression part. Okay, and what this file basically does, it goes through every line of the file, of the input file, and then it looks for this pattern, which is the one I'm highlighting right now. It will look for this pattern, and if it matches, it will push that line to the matched array. And if it's not matched, it will put it into the unmatched array, and in the output it will show you which line is matched, which one is not matched. Okay, so basically, okay, so let's the first demonstration is, okay, you have the so let's say you want to match any kind of alphabet letters, from A to Z basically. You can do the escape W. Okay, and that pretty much matches one single character of alphabet letters. Okay, in addition, the escape W also matches numbers as well. Okay, it also matches a number as well, and it also matches underscore. Okay, it also matches underscore. So if you put escape W, it just means look for one alphanumeric character. Okay, so look for one alphanumeric character, just one. Okay, so if we do that, okay, and we run it, Okay, and I use a sample file. Okay, so now you see, look at here. Okay, every line has a letter, right? That's why it matches. That's why it matches all of them. Okay, and every line has a number as well. Like, you know, it can be number or letters or underscore. See, also it matches. It will match underscore as well. Even though you don't see it here, but it does match underscore. Okay, so that's matching one characters only. Okay, one alphanumeric character. Okay, now if we open it and we look for just the numbers, if we just want the numbers, okay, then you will put the escape D, okay, for just the number. So that escape D means just one single digit, one single number. That's it. Okay, so if we write that and run it, okay, now you see that, like, you know, lines that have numbers, you see lines that have numbers are matched. Okay, and lines that do not have numbers, okay, they are not matched. So escape D is for numbers. Okay. Okay, so now if we want to match empty space, right? Empty space is escape S. Escape S is matching for like empty space. Okay, yeah. So if we write that and run it, okay. So basically every line matches because the escape S also matches a new line as well. Okay, so that's why it also matches the that's why it matches all the lines in there, pretty much the whole file in there. So you don't see any unmatched there. So that's what escape S is. Okay. Now, if you want to say you don't want to match white space or new line, okay, you could capitalize it. Okay, and what that does, like, so whatever that's capitalized means the opposite of the whatever they're doing. So escape capital S is the opposite of escape lowercase s. Okay, now remember the lowercase s means match empty space or a new line. Okay, so escape capital S means do not match empty space or new line. Okay, so if we do that and run it, okay, that's the reason why we still match everything is because we have non-space characters in every line. Non-space characters in every line. Okay, so that's why we have that. Okay, so if we open this one, so let's say you're looking for all the lines that do not contain a number. Okay, remember the escape lowercase d means look for a number. Okay, now escape capital D means do not look for a number. So any lines that do not have a number will be matched. Okay, see, they do not, and the reason we have every line is because there's a new line in every character. That's why everything's matched. Okay, if we don't have a new line in there, they will not be you know, they would be considered, you know, like this one, you know, this one will not be matched because since it has a new line character in there, it's still getting matched. But basically, you know, anything that's capital is the opposite of what their lowercase version does, basically. Okay, so I'm not going to go over the capital W again. It's basically the opposite of the lowercase w. Okay, now what you can do is like let's say you want to look for something, look for a line where the beginning of the line contains a number, right? So what you can do like a caret in there, like a hat, little hat in there, right? The little hat means the beginning of the line. So what this regular expression means, like the hat and then the escape D, okay, that means, like, you know, look for any lines that starts with a number. Okay, so if we run it, okay, now you see that all the lines, okay, only if it starts with a number. Okay, only if it starts with a number, then it will show up. Okay, and if we do it with alphanumeric character, okay, you see all these starts with some kind of a number or letter, right? And the unmatched one is like this one doesn't match because this one has a space, okay? And this one doesn't match because there's also a space in front of this one. You don't see it because like but there's a space before it, basically. And then this one is because it's more like a punctuation or percentage sign, so that's why it does not match. So that's what the hat is for. Okay, that means it starts with something. Okay, if we look carefully, we can do like anything that starts with fuzzycast if you want to do that. So you can type in fuzzycast. Okay, write it and then run it. Okay, now you see that all the lines that start with the fuzzycast are being displayed. Okay, so that's what the hat is for. Now you can do something that you can look for something that ends with something. So let's go back there and see what do they have. Something that ends with something. Maybe something that ends with the world, right? Something that ends with the world. Okay, so you go in there. You type in the world, okay, and you also type in the $sign. Okay, what $sign means is that the end of the line. Okay, $sign means the end of the line. So if you run this, you will see that, okay, anything that ends with the world will show up. Okay, and then the other ones they do not match. So that's what basically what it is if you're looking for the beginning and the end of the line. That's what those two signs are, the hat and the $sign, basically. Okay. So what if you just want to match any character? It doesn't matter what kind of character it is. It just has to be a character, right? So what you can do is that you can do it a period. Okay, a period. That means it's any character. It doesn't matter what character it is, except for new lines. Okay. So so this will not match new lines unless we put in an S flag. If we put in an S flag, then the new line will be matched. Otherwise, it will not match. Okay. So if we write this, run it, everything matches because it matches any kind of character. It doesn't matter what kind of character it is. It will match any kind of character. Okay. So that's basically how you match. There's also like other kind of matching, like the word boundaries and everything, but the basics is right here. The basics is right here. So for the other ones, I will go over in the future videos, and I'll talk about it in the future video. So far we look at single character, right? Every type of character we look at, we're always looking for one single character. We're not looking for multiple characters. Okay, so let's do something that way we can look for multiple characters, right? So let's say we want to look for a digit, and it can be okay, here what this means, like the star means is a zero or more occurrences. Okay, so if you put so escape D star means look for 0 or more numbers. Okay, because star means 0 or more occurrences. So that means so escape D is looking for one digit, one number. But if you put a quantity, right, quantifier, basically star is like a quantifier. It's saying that, oh, how many digits are you looking for? But when we put in the star, it means let's look for 0 or more number digits, 0 or more digits, basically. Okay, so if we run this. Okay, so write it. Okay, and you run it. Okay, everything still matches. Why? Is because like you're looking for 0 or more. Okay, you're not looking for at least one. Okay, so that means these, right, even though they don't have number, they match. And the reason is because you're looking for 0 or more. So there can be no number and it will still match. Okay, so what if you just want to look for something that has a number, right? That has a number. So you can put in a plus sign. Okay, now plus sign is also a quantifier. Okay, it specifies how many how many digits you're looking for, basically. Okay, so it's a star and the plus sign. They're all like same type of function, like a same type of, they belong to the same category of function functionality. Basically, they quantify, they specify how many digits, how many digits you're looking for. So the plus sign means is that the digit has to be at least 1 or more. Okay, so there has to be at least 1 digit or more, okay, for it to be matched. So right now we write this, okay, we let it run. Okay, so now you see like the numbers, the unmatched do not have numbers anymore, but the matched ones have numbers. Okay, and that's because we're looking for at least, okay, at least one digits basically. Okay, so that's why these are all matched, and these one here do not match because they don't have a number. Okay, so plus sign means 1 or more occurrences. Okay, now there's another one, is a question mark. Okay, question mark is also a quantifier. It's also a quantifier. Okay, so it specifies the digit must be shown up at least 0 or 1, basically. Okay, so the number so look for a digit. Okay, it can be 0 digit or 1 digit, basically. Okay, so if we run this, okay, you see everything still matches. Okay, and that's because the we're looking for 0 or 1 digit. So if a line has a 0 digits, we match. If the line has 1 digit, we match. So that's why we matches every line of them. Okay, now you of course I'm just showing basics, but of course you can be very flexible into like what exactly you're looking for, and we will do that. We'll have an exercise at the end of this session, and we're basically going over a little bit more complex, not really complex, but then a little bit more complex than we think. Let me basically do an exercise and show you what regular expression can do, basically. Okay, so that's what it is. So you can have like a escape W, looking for one character, one alphanumeric character. I mean, looking for 0 alphanumeric character or 1 alphanumeric character. So 0 or 1, basically. Okay. So, and then you can have like a white space. You can look for 0 or 1 white space. Or 0 or 1 alphanumerics. You can have at least 1 space or more. Okay, so the space has to be at least 1 or more. So if we do that, there has to be at least 1 space. Okay, and remember the escape S also matches a new line as well. So that's what we still see, like all these characters in there. Okay, we still see all these lines in there because the escape S matches the new line, basically. Okay, so you can be so far we look at looking for a character that's like a 0 or more occurrences. We are looking for characters that have like 1 or more occurrences, and we are looking for the characters that are like 0 or 1 occurrences. So what if you want looking for something that's like minimum 3 occurrences, or you're looking for maximum 5 occurrences, or if you're looking for maybe a range between 2 and 5 occurrences of a specific expression. So you could do that with the range quantifier, Okay, so let's say you're looking for digits, right? And you say you want at least 2 to 5, okay, digits, basically. So if a line has 2 digits, 3 digits, 4 digits, 5 digits, they will be matched. Okay, if the line has more than 5 digits, then they will not match. Okay, so if we write this, okay, and run it, okay, so now you see all these match, right? All these match. Okay, and you see that this is matched, and why? And that's because this has 5 characters, basically. Okay, this has 5 characters. You didn't specify that whatever following the 5 characters cannot be a digit. You just say you're looking for 5 characters, 5 digits, basically. Okay, so in our regular expression, we didn't specify after 5 digits it cannot be a number. We didn't say that, and so that's why this line matches. Okay, It's basically it's not restricting any kind of like numbers. It's just looking for 2 to 5 digits. Okay, it doesn't say it cannot be 6 digits basically. Okay, because you didn't specify that it cannot be 6 digits. Okay, so that's the range, right? That's the range quantifier basically. So let's say you want to say you have at least 2 digits, right? At least 2 digits. So that's how you specify it. With open braces, 2, comma, and then you don't specify the maximum number of digits. Okay, just leave it empty, and then the closing braces. Okay, so if you do that, you're looking for basically at least 2 digits. Okay, so let's say we want looking for at least 5 digits. Okay, at least 5 digits. Okay, so if we do that, okay, so only these 2 lines have at least 5 digits basically. Okay, so that's why that's what it is, how you specify the minimum quantifier. That's how you specify it. Okay, so if you want to get if you want to match like a digit that's like 4 times, right? So you want to match a digit where is exactly 4 times. Okay, so you can just put in the open braces and then the number of occurrences and then the closed braces, and you will be able to get the a specific number of occurrences. So if I put in escape D, open braces 4 and then closed braces, and then I run it. Okay, so now all the matching only has has to be 4. It will look for at least 4 digits in there basically. Okay, and the other ones that it can be there or not, doesn't really matter. But you realize when you look at this, right, there's only a 3, 1, 3, 3. I mean, they're not matched basically. Okay, and next one is character classes. Okay, character classes is more like used often in the Unix commands. Okay, so instead of like digits, right, what they do is they do 0 to 9 range. Okay, so this is the character class. Okay, or character set, and you specify the specific characters you're looking for, or the range of the characters you're looking for basically. So if I put 0 to 9, it's equivalent to the escape D. Okay, so if I run it, okay, same result basically. Okay, and we can do like you can do A to Z or whatever you want, basically. So let's say I'm trying to match A, B, A, T, Z, and then let's at least once, right? So if we run this, okay, only the characters that have A, T, C will be matched. Anything else, they do not match basically. So this is the character class basically. Okay, and you have the inverse of the character class. So let's say you're looking for something let's say you're looking for something that's not a number, right? So it will be 0 to 9 with a hat before it. Okay, with a hat before it. So that means that's the inverse. That's the inverse of the character set. That's basically saying don't look for any numbers between 0 to 9. Okay, so if we set to 4 occurrences, we run it. Okay, so basically this one become not matched. Okay, because it has more than 4 digits basically. When we look at our pattern, right, we're saying basically any character, right, that's not a number, and then we repeat for 4 times. So basically any non-number characters that occurs 4 times basically. So that's why we see all these in there, right? The Fusi cast 2012. That's because we have Fusi or any of these characters, right? They are not number, and they'll repeat as at least 4 times, right? And then we look at here, because of these non-numeric characters in there. That's why they are being matched. Okay, and this is not being matched because it only has a numeric characters, and it's at least 4 times already. Okay, And the next one is the non-greedy. Is something called non-greedy. Actually, let's go over the alternation, right? So if you look at the string here, right? This one, these two strings here. Okay, so let's say I want to match for something that's like in the fuzzy cast is either great or wonderful, right? I want to match lines that have either great or wonderful. So I go in there, okay. Take this out. I say fuzzy cast is okay, and then I group it. I don't need to group it. That's great or wonderful. Okay. So this is a pipe, right? This little pipe thing over here, the vertical line here, it means it's or. So it's either great or wonderful, and it will match these two patterns basically. So if we write this and we run it, okay. So now you see these two are matched, okay, because this contains great and this contains wonderful. So it's either one of them, and then it will match basically. So the pipeline is basically an or, an alternation basically. It can be great or it can be wonderful, basically. Okay, so let's go with some quick samples here. Okay, and then I'll go over them again in the future if it's a bit confusing. So here I have a exercise 1 script. Okay, exercise 1. Okay, and then I have this log. I have this HTTP log. Okay, now when you look at the HTTP log, right, you see a lot of information in there, and you're trying to get the information out, right? So you have the IP address, okay, you have the timestamp, okay, excuse me, you have the HTTP protocol version, which is 1.1 here. You have the return status code here, okay. You have the user URL here. Okay, this one doesn't just have a hyphen, but if you look at over here, okay, you see a URL here, okay, and then after that you see a user agent. Okay, it's a Mozilla. Okay, so you see you have these logs, right, and you're trying to get all these information. Let's say you want to get all these information out, right? You could use a regular expression to grab all these grab all these information out. So in this example, okay, I have a regular expression here. Okay, up to here, yeah. Okay, so this is the part of the regular expression. Okay, now if we analyze this, we look at this. This is looking for something that begins. Okay, that begins, and then we have a grouping. Okay, what grouping does is that grouping is able to save the pattern that's matched, and then store it into these variables, $1, $2, $3, $4, $5, and so on, depending on how many groups you have. So in this case, I have like six groups here. So I have like 6 sets of parentheses basically. Okay, and this is the first set. Okay, so I have the open parentheses. So I'm starting the first group. Okay, I'm looking for digits, and the digits has to be at least 1 digit or more basically. Okay, and then I'm looking for a period. Okay, now notice that I use a period. I have to escape this. Okay, I have to escape this period because the period in regular expression, remember, it means any characters, right? So we don't want it to have any special meanings. We want to literally match a period. Okay, we don't need to have it. So anything that's like a part of the regular expression syntax, and you add that those are the characters that you are actually looking for. You're not trying to use those regular expression syntax. You are actually looking for that specific, like say the question mark, or if you're looking specifically for a star, asterisk, or if you are specifically looking for a plus sign, or the if you're looking for specifically those special characters, you have to escape them. Okay, and when you escape them, the regular expression will understand that you're not using this period to match any character. You're using this period to actually literally match a period basically. So we have a set of numbers, okay, followed by a period, and then followed by a set of numbers, followed by a period, a set of numbers, a period, and a set of numbers. So you notice that we have number, period, number, period, number, period, and number. Okay, and this matches the IP address we have here. Okay, we have number, period, number, period, number, period, number. Okay, so this basically matches the IP address here. Okay, and then here we have the period star. Okay, period star means I match any character, 0 or more occurrences. Okay, so it will match any kind of characters. Basically, doesn't matter what character it is. Okay, except for the new line anyway. But this comes to a problem because if you do a period star, it will match all the characters from right after IP address to the end of the line, because these, from here to the end of the line, they all characters, right? So this will match all of it because it's just looking for any kind of characters. Okay, so this so period star will match all the way from here to the end of the line, but we don't want to do that because we want to also grab the timestamp as well. Okay, we want to grab the timestamp as well. So we put in a non-greedy pattern matching, where we put in a question mark after the star sign. Okay, so if we put a question mark behind it, right, that means it's looking for it will match any characters, okay, of any kind of quantities, okay, up to where it will see a square bracket, an opening square bracket. So it's basically saying it will look for any characters, okay, up to a square bracket, basically. Okay, and that's what we're doing. We're matching any characters, okay, up to a square bracket. Okay, and then we stop at here. Basically, the regular expression stops at here, and then it continues on. Okay, and then looking for the next group. Okay, the next group is saying that grab any characters, okay, up to a closing right bracket. Okay, so it will look for all the any characters. Look for any characters. This matter, these will all be matched, and then up to a closing square bracket. Okay, so basically it will match these part, basically. Okay, because it says match for any characters up to closing bracket, up to the first closing bracket. So we just stop at here. Okay, so we grab that, we put it into the $2 variable. Okay, and then followed by that, we're looking for any characters again up to HTTP character. Okay, so we look for any characters, and then we hit the HTTP, and that's when we stop. Okay, that's when we stop. Okay, and then we basically look for any number of characters here again up to a single double quote. Okay, so right after HTTP and then the slash, okay, and then it will start to match any characters, okay, up to a double quote. Okay, so here it meets it stops here HTTP slash, and then it will start matching any characters up to a double quote. So it will match any characters, and then it will stop at here because it says up to the double quote. Okay, so it will grab this 1.1 and then save it into the $3 because we have a group around it. We put a group around the numbers, basically. So it will store into the $3. Okay, and then it will go forward, and then it starts with another group. Okay, it has a white space here, so we have a we basically have a white space here. Okay, and then it's looking for numbers, basically looking for numbers. Okay, and then we have a number here which is 200. Okay, so it will save that, okay, into $4. That's the fourth group. Okay, so after it matches that, and then look for any characters again. Look for any characters again up to the double quote. Okay, so we look for any characters. So from here, it will start looking for any characters up to a double quote. So here, excuse me, here it hits a double quote. Okay, and then it starts another group. Okay, and then inside the group, it will look for any characters again until it hits the another double quote. So it look for any characters here up to another double quote. Okay, so it saves that little hyphen there, and then save it into the $5 basically. Okay, and then after that it look for white space and then a double quote. So we have a white space here, double quote here. Okay, and then it look for any characters again. Okay, up to an open parentheses. See, we escape the open parentheses because we're looking for specifically that. We're looking for literally that open parentheses. We're not trying to do another grouping. We are looking specifically for that open parentheses. So it basically match any characters up to a open parentheses. Okay, so last time we start by here. Okay, and then it will match any characters. Okay, and then it hits a open parentheses, and then it says, oh, stop. Okay, and then it will save this group into the $6. Okay, so here we introduce a concept of the non-greedy pattern matching, where if we're looking for any characters, right? If we just put in period star, it will match everything. It will not try to determine, like, which one is the timestamp, which one is the HTTP protocol versions, which one is the return status, which one is the URL, and which one is the user agent. It will not do that because you're looking for any characters. Doesn't matter what kind of character it is, except for new lines, right? So it will hit up to the new line basically. Okay, that's the greedy method. Okay, that's the greedy method because it will match any character. But since we put a question mark behind this, right? Put a question mark behind the star. It means do it in a non-greedy way. Okay, so it will basically look for. It will basically look at the character after the question mark. Okay, if we see this character there, we'll stop. Basically that's what it's saying. Okay, if we see this character, okay, so basically it will match any characters, and then up to, and then when it sees a square bracket, it will stop. Okay, it will not try to match the whole line. It will just match until it sees a square bracket. Okay, so that's the non-greedy pattern matching basically. It's a little bit confusing, and I will go over it a little bit more next time. But this is just like an introduction, just introducing the regular expression. So I will be going over this again and again in the future videos, so that you will understand what these non-greedy and greedy pattern matching means. Okay, so let's give it a run, right? Let's give this a run. Okay, we do pro exercise 1, and then put in the input file. Okay, and then you will see that, from that log, it's able to grab the IP address, it's able to grab the timestamp. Okay, it's able to grab the 1.1, the return status, the URL. The first line, the URL is just a hyphen, but then the second line, okay, you see, it has a URL. Okay, so basically it has a URL, and then this has a user agent, so it grabs the user agent as well. Okay, so you can see that you can use regular expressions to grab all different kind of informations that you need in the log file, and you can just do it with how many lines? We just 2-3 lines. That's it. That's all you need. Okay, that's the power of Pro. That's why I like it, because it's very the codes you write can be very concise. Okay, you just need 1 or 2 lines, and you can do a lot of stuff. Comparing to Java, which you have to declare all kind of different stuff before you get started. Okay, so this is it. This is what the introduction to the regular expression. In the next episode, I will be going over a little bit more advanced topics. I haven't planned out what to talk about in the next video, but it should be pretty interesting because I really like the regular expression. And also you have like so many different flags you can put in here at the end. Okay, but these videos, my main focus is on the regular expression syntax. I'm not looking to show you the pro syntax. So that's why you don't have to worry about this like the first slash and the last slash. Okay, not right now, at least not right now. Okay, in the next video I'll show you why we have this, and you know, and then you will understand why, you know, how wonderful pro is. You just need to do this and you already match everything. Okay, so you know, keep watching the regular expression videos, and hopefully you will be mastering it in the future. So stay tuned for the next video on regular expression. Thanks. Hey guys, thank you for watching my videos. Make sure to subscribe to me, to like me on my Facebook page. It's facebook.com/FusiCast, and also make sure to follow me on the YouTube channel. It's youtube.com/UJDesigner85, and also my blog, which is thefusicast.com. Thank you.